Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 5, Linear Programming. Exercise, Miscellaneous Examples on Chapter 12. Miscellaneous Examples on Chapter 12. Question number 1. A dietitian has to develop a specific diet using two foods P and Q. Each packet containing 30 grams of food P contains 12 units of calcium, 4 units of iron, 6 units of cholesterol, and 6 units of vitamin A. Each packet of the same quantity of food Q contains 3 units of calcium, 20 units of iron, 4 units of cholesterol, and 3 units of vitamin A. The diet requires at least 240 units of calcium, at least 460 units of iron, and at most 300 units of cholesterol. How many packets of each food should be used to maximize the amount of vitamin A in the diet? What is the maximum amount of vitamin A in the diet? Let X and Y be the number of packets of food P and Q. Let Z be the maximum amount of vitamin A. Then the problem is to maximize Z equal to 6x plus 3y. Food asida yauriba vitamin A gi unit asi 6 amasung 3 units ni mathang sitna. Therefore X packet tadi Y packet tadi 6x plus 3y lerani. Subject to the constraints, 12x plus 3y should be greater than or equal to 240. Haibadi 240 haibadi diet sing adu da yamdrabada mix tawraba diet adu da develop togadaba diet adu da yawgadaba calcium si yamdrabada 240 units yawallo haibani 240. adu food p da yawri ba calcium si 12 units ni packet amada adugumba x da 12x lerani. Food Q gi mahaki packet amada yauriba calcium asi unit ahumni adugumba packet y da thrice y ni ani se sum up tawraga phangiba value ase yamdrabada mahaki 240 units of calcium yawallo haibani greater than equal to 240 orani. Dividing tawrabadi we get this asumna calcium ki loikre mathangda iron gi amuk try tawsi iron gi amuk limitation sing adu yengsi. 4x plus 20y haibadi iron gi di food p da packet amada 4 units of iron yawi haibani adugumba packet x da 4x lerani. Food q da di iron gi food q gi unit amada packet amada iron gi unit 20 yawi haibani adugumba y da 20y lerani. Ani zigi sum up toraga phangpa unit masing ja iron masing ni hairiba masing ase diet adu da yamdrabada iron gi unit si 460 dagi tahangano haibani sumna greater than equal to 460 lerani. Simplify toraga si phang iron gi loikre mathang da cholesterol amuk yengsi 6 amasung 4 ni adu 6x plus 4y cholesterol asigi di yamabada 300 units at most 300 units of cholesterol haibani less than or equal to 300 leri. Simplify tawrabadi thrice x plus twice y less than or equal to 150 lerani. The n, x and y should be greater than equal to 0 non-negativity restriction leri. Continue question number 1. The graphs of the equations 4x plus y equal to it ne divide tawrabadi intercept from the thame x plus 5y equal to 115 ki di 115 divide tawrabadi si phangani. And ani subagi di ahum subagi di si phangani 150 na tang kudimakta divide tawrabadi si phange. And x equal to 0 y equal to 0 are the lines ahan bagina ab ani subagi na cd ahum subagi na ef aduga x equal to 0 gi graph ti y axis ni y equal to 0 gi graph ti x axis ni respectively is in this picture. sina horizontal line asina x axis ni, vertical line asina y axis ni. On origin kore ahanba line AB haragadi sigi line asigi equation du sini mahaki inequality du di kona amuk khanarasi ani suba line adugi graph ti mahaki di CD ni line asini aduga ahum suba dugi di EF lere EF habidi sigi line asini. Inequality sing adubusun x equal to 0 x equal to 0 haragadi y axis ni, y equal to 0 haragadi x axis ni. Inequality sing adudi ahanba line AB asigi di upward asina mahaki half plane adu orani aduga CD hariba ani suba line adugi line asigi above si orani ahum suba line gi inequality di line asigi downwards asini. X greater than equal to 0 gidi y axis के right ward ni, y greater than equal to 0 gidi x axis के upward ni. Hariba inequality manga sibu cover to common region decided region PQR hariba point asini. Hariba point singa sigi coordinate singa dudi newly akoi line singa sibu represent toriba equation anidugi solution toraga P gi coordinate to 40 15 phangani. Q की coordinate line ani sibu represent toriba equation ani si solve toraga any technique ama sizinaraga solve toraga Q की coordinate sing phangani sumna R hariba point asigi coordinate su line ani sibu graph ani sibu represent toriba equation ani do solve toraga R की coordinate phangani sigi result asini feasible region haribasi. The shaded region PQR is the feasible region with vertices P gidi 40 15 Q gidi 15 Q gidi 15 20 aduga among and R gidi 217 to 272 asini. Hariba points hariba corner points singa sida Z ki value putoksi corner points singa sida Z ki value at P da Z की value at P 40 15 is Z की value the 6 into 40 plus 3 into 15 the 240 plus 45 285 lady at Q da 15 20 is Z की value the 6 into 15 plus 3 into 20 that is 90 plus 60 equal to 150 lady. 8 R da 272 is Z की value the 6 into 2 plus 3 into 72 that is 12 plus 2 16 2 to 8 phangani point value ahum se phange value ahum sidagi maximum di that Z is maximum when x is 40 x is 40 and y is 15. Therefore the maximum amount of vitamin A is 285 units when 40 packets of food P and 15 packets of food Q hariba packets sing si sarabadi vitamin A gi maximum amount is 285 phangani. For question number 2, a farmer mixes 2 brands P and Q of cattle feed. Brand P costing rupees 250 per bag contains 3 units of nutritional element A, 2.5 units of element B, and 2 units of element C. Brand Q costing rupees 200 per bag contains 1.5 units of nutritional element A, 11.25 units of element B, and 3 units of element C. The minimum requirements of the nutrient A, B, and C are 18 units, 45 units, and 24 units respectively. Determine the number of bags of each brand which should be mixed in order to produce a mixture having a minimum cost per bag. What is the minimum cost of the mixture per bag? Farmer amana cattle feed P amasung Q haiba brand ani mix tawgani. Brand P asi bag the lupa sani yankai P masida nutritional element A B C singadu makoigi unit singadu mathang sitna 3 units 2.5 units 2 units yawi. Brand Q asina bag amadu lupa chani P masida nutritional element A B C singadu unit mathang sitna 1.5 11.25 3 units yawi. The minimum requirements of nutritional ABC are 18 units, 45 units, and 24 units respectively. Adugumba mixed together diet cattle feed aduda yaugadaba elementsing A B C sing yamdrabadi unit 18 45 units amasung 24 units sing asi mathang sina yamdrabadi yahungadabani. Determine the number of bags of each brand which should be mixed in order to produce a mixture having a minimum cost per bag. Bag amada khwaidagi yamdaba paisa piba apamba diet nutritional elements si yahungadaba adugumba makhal animaki bag kaya puto saga kaya legadagi. What is the minimum cost of the mixer per bag? Bag mixer toraba mix toraba bag amagi khwaidagi yamdaba maman adu kayano. Let X and Y be the number of bags of brands P and Q. Brands P amasung Q gi laigadaba bag masing adu mathang sina X amasung Y uhillasi. Let Z be the minimum cost of the mixer per bag. Z na mix toraba bag amagi khwaidagi yamdaba paisa duni haina laurasi. Then the problem is to minimize Z equal to bag masing duga makoi respective cost pricing aduga purinaraga sum up torabadi sine minimum cost pangani of the mixture subject to the constraints restrictions sing adudi nutritional element A gidi thrice x plus 1.5 this should be greater than equal to 18 high with the mixture adu the yamdrabada nutritional elements 18 yahlo higher banina greater than equal to 18 or simplified or the safe hangani assume nutritional element B gi amokhanasi mahakidi 2.5 units B yawe aduga x unit study 2.5 x plus asumna 11.25 times so y should be greater than equal to mark minimum requirement the 45 units ni simplified toroga si phangani for nutritional elements C the twice x plus 3y this should be greater than equal to 24 or any and x and y should be greater than equal to 0 hauji phawbadi aikoina equation asigi formulation toba. Next graph the graphs of the equations twice x plus y equal to 12 na divide over the siphangi twice x plus 9y equal to 36 na divide over the siphangani and twice x plus 3y equal to 24 na divide over the siphangi x equal to 0 and y equal to 0 are the lines A, B, C, D, E, F, Y axis and X axis respectively as in this picture. The feasible reason adu the inequality sing adu suman badi line sing adu gi mathak line AB gi sumathak thangba sarukni BC gi CD gi sumathak thangba sarukni EF gi sumathak thangba sarukni mathak thangba sarukni x greater than equal to 0 gi su y axis ke right wani y greater than equal to 0 gi su x axis ke up wani common reason adu the shaded reason asigi boundary amasung reason asteleba point kuding mangna inequality manga asibu chumalle the shaded reason CPQB is the feasible reason with vertices C gi 18 ni P gi solve toraga phangi 9 to Q gi solve toraga phangi 36 and B whose coordinates are 0 12 ni hariba corner point single sida Z ki value putoksi HC the value of Z is watakim objective function the sinjala 250 into 18 plus 200 into 0 the 4500 phangi assume 8p the z ki value the 250 into 9 plus 200 into 2 that is 2650 phangi 8q the z ki value simatang sina 1950 phangi 8b the z ki value su 2400 phangi value mayam sing sigi manung dagi minimum or maximum sing adu kona yam line na khangle thus minimum z is 1950 that is when x is 3 and y is 6. Hence, the minimum cost of the mixer per bag is rupees 1950 orani when number of bags of put P do not 3 orani and the date of Q as in 6 bags like oigani. Question number 3. A dietitian wishes to mix together two kinds of food X and Y in such a way that the mixture contains at least 10 units of vitamin A, 12 units of vitamin B, and 8 units of vitamin C. The vitamin contents of 1 kg food is given below. Food XY, vitamin A, vitamin B, vitamin C, and food X, the vitamin AC unit amayawi food X the vitamin B C 2 units, put X the vitamin C unit 3. Assume na put Y gisu 2 to 1 yaw unit sim. 1 kg of food X costs rupees 16 and 1 kg of food Y costs rupees 20. Find the least cost of the mixture which will produce the required diet. food x ki kg amada lupa tratu food y ki kg amada lupa kun pi khwaidagi apama diet adu phangnana ba least cost of the mixture adugi khwaidagi yamdaba paisa adu puthu ahan bada this is similar to question number 2. No, we are left. Next, question number 4. A manufacturer makes two types of toys A and B. Three machines are needed for this purpose and the time in minutes required for each toy on the machines is given below. Type of toys A, B, machines 1, 2, 3 and minutes used in processing 12, 18, 6, 4B, 6, 0 or 9. Each machine is available for a maximum of 6 hours per day. Machine khudungmak nomada pung taruk thabak suba yai yamabada. If the profit on each toy of type A is rupees 7.5 and that on each toy of type B is rupees 5, so that 15 toys of type A and 30 of type B should be manufactured in a day to get maximum profit. Type A gi 15 amasung type B gi 30 saraga nomada maximum profit phangi habasi utlu haibane. Let x and y be the number of toys A and B. Toy A amasung B gi sagadaba nomagi sagadaba masing x amasung y laurasi. Then the problem is to maximize z equal to 7.5x plus 5y. Subject to the constraints 12x plus 6y should be less than equal to 6 hour. The minute sadok labadi 60 lere simplify targasi lere asumna mathangi su machine to the process tawagi phangiba timing is 6 hours the minute sadok 60 lere ne sidi 18x plus 0y simplify targadi x less than to or equal to 20 mathangi machine 3 the process tawagi 6x plus 9y seasonal timing is sini phangiba timing na 6 hours so converted into minute. We simplify, we get this. And x and y should be greater than equal to 0. How's problem asigi formula double low. Continued. The graphs of the equations twice x plus y equal to 60, 16 divided receive x equal to 20 and twice x plus 3y equal to 120. 120 divided receive x equal to 0 and y equal to 0 are the lines A, B, C, D, E, F, Y axis and X axis respectively as in this picture. The feasible region is the shaded region O, C, P, Q, F with vertices origin की 0 0 लेरनी C की graph yakpada तेमत खंगे 20 0 ni P हरिबा point aside line ani sibu represent over equation ani do solve तोरगा फंगी 20 20 लेरे Q हरिबा point asi line ani sibu graph and line ani sibu represent over equation ani si solve तोरगा फंगी 15 30 F हरिबा point aside graph yakpada खंगे 0 40 ni hariba singshina corner point singni. At O, the value of Z is 7.5 into 0 plus 5 into 0 na 0 pire. At C, Z की value सो असुमना पुथो है. At P, Z की value सो असुमना पुथो अने. At Q, Z की value सो पुथो लनी. At F, Z की value सो पुथो लनी. Value मायाम सिंची के मानुंग दगी minimum. Thus, maximum Z is Z के ख्वाइदेगी सावा value दी 262.5. At masi x की value na 15 amasu y की value na 30 warakanda chume. Hence, maximum profit occurs when number of type A and B are 15 and 30. 15 amasu 30 sarakanda chume. Akona wahang adugi proof tore. Question number 5. An aeroplane can carry a maximum of 200 passengers. A profit of rupees 1000 is made on its executive class ticket and a profit of rupees 600 is made on its economy class ticket. The airline reserves at least 20 seats for executive class. However, at least 4 times as many passengers prefer to travel by economy class than by the executive class. Yamdrabada Mari Rakti economy class asina executive class the passenger masing heli. Determine how many tickets of each type must be sold in order to maximize the profit for the airline. Airline adugi maximum profit lenabagi damo ticket makal anido kaya yongadagi. What is the maximum profit? Maximum profit kaya no. Airline aeroplane amana passenger chani pubangami executive class ticket amadi lupa lising ama tongi economic class ticket amadi lupa chatruk tongi yamdrabada executive class ki 20 seats reserve tawgani यामद्रबदा मरीरक्ति इकोनॉमिक क्लास की टिकेट मसिंग सिना एग्जीक्यूटिव क्लास मसिंग दगी हेनबे नुमिसिंग थे यावे टिकेट मखल अनिमक कया कया योलबदी सेंदोंग हेन लाकदगे maximum profit adusu putu. Let X and Y be the number of tickets of executive class and the economy class tickets. Hariba makal animak to X amaso Y putuk lasi yolasi. Let Z be the maximum profit. Z the maximum profit on a low lasi. Then Z is ticket ama executive ama diglising ama tonga de duguma X to yon probably 1000 X line assume 600 Y line subject to the constraints X plus Y ticket passenger masing degi hena ticket yon be yadi X plus Y number of tickets to be sold doni should be less than or equal to number of passengers maximum passengers 200 ticket pick kane and X should be greater than equal to 20 X to executive class के ticket से मारी 20 रिजर्व नहीं यामद्रबदा 20 ने मारी कोई passenger संगदोरिसी हेनबे याई and the Y should be greater than equal to 4X having executive class ticket masing asagi 4 times na economic class na hena chatle have and the X and Y should be greater than equal to 0 hojik phawbadi formulation lori continue. The graphs of the equations first one with x plus y equal to 200, x equal to 20, y equal to 4x, x equal to 0, and y equal to 0 are the lines. Ahan bagina AB korasi, ani subagina CD korasi, ahum subagina EF korasi. Mari suba x equal to 0 the y axis ni y equal to 0 the x axis ni respectively. However, graph adu sumna x plus y equal to 200 the AB line asini. X equal to 20 hadi right water y axis ke right water x equal to 20 asini asumna y equal to 4x hadi origin power 6 that line asini x equal to 0 hairagadi y axis puni y equal to 0 hairagadi x axis puni. The feasible region is the shaded region CDP. CDP hariba shaded region sina feasible region with vertices CD solve toraga fange line and is represent of equation and it solve toraga fange haibadi y equal to 4x x equal to 20 solve toraga the C coordinate 20 IT line and the P coordinate line and is represent of equation haibadi y equal to 4x x plus y equal to 200 solve toraga we get 4160 fange and D coordinate is 2180 fange. At the value of z the objective function that sinjalaga ikona si fange at d the z ki value number si fange at c the z ki value asumna fange number mayam singa si maximum over the 0 1 to 8000 sino ore thus maximum z is 138 ohum at x equal to 40 and y equal to 160. Hence, the maximum profit is rupees 13,600 or 1,36,000 when number of executive class tickets is 40 and number of economy class ticket is 160. For question number 6, two godowns A and B have grain capacity of 100 quintal and 50 quintals respectively. Godown anigi grain singi capacity si 100 quintals 50 quintals singi A B mathang sina. They supply to three ration shops D, E and F whose requirements are 60, 50, 40 quintals respectively. Hariba mafam singa sidagi godown shop D, E, F haibasing asida makoigi requirement is 60, 50, 40 quintals oversee the supply to Gudrimni. The cost of transportation per quintal from the godowns to the shops are given in the following table. Godown singasidagi shop singasida port tabagi quintal namagi paisa singa the rupees the makara piri. From a godown dagi D the transport over the quintal namagi the lupata ruklowe asumna a godown dagi E shops asida transport of the quintal namagi grains ku quintal amagi athaman lupa ahumni A dagi F the tabana 2.5 asumna B dagi godown B dagi shop D the tabada quintal namad lupa mari lowe E the taragana lupa ani F the taragana lupa ahum. How should the supplies be transported in order that the transportation cost is minimum? Transportation cost minimum oinabagi dama karanna supply tawgudagi. What is the minimum cost? Transport is minimum cost of transportation adusu puthu haibani ahanbada identify the decision variables identify togani. Let x and y be the number of quintals to be transported from A to shops D and E respectively. A go down the DE haiba shopsing asida thaki kadaba quintal singi masing x amasung y logsilasi. Then 100 minus x plus y quintals to be transported from go down A to the shop F. Go down A dagi go down A dagi shop F to thagada badudi mahaki lariba 100 to dagi transported tokiba anido kaido lemhoriba to supply togadabani. Also 60 minus x a dagi d da x transportation tawde magi 60 darkar oibadi x hana phangba hokrabadi b dagi mangonda thara kadoribasi watloriba 60 dagi x khaidokagleiba quintal masingduni thara kadoris asumna b dagi e da thara kadaba asina mahaki hana y mangonda y phangre a go down dagi e have swapsina y quintals phangre watloriba 50 yongana 50 minus y watloriba do b dagi somda transported tawrakani. Amuksu A dagi F to thaki ba quintal masing the mahana 40 darkar oibani 40 darkar oibada mahana khara tharak khare aduri 40 dagi A dagi F to thaki ba quintal do khaido khrabadi madugi awat paduna B dagi F to tharakada bani madu x plus y equal to x plus y minus 60 ore. These are to be transported from B to D E F respectively. Let Z be the minimum cost of transportation. Khwaidagi yamdaba minimum cost of transportation to Z on a loxalasi. Then Z is what? 6 into X plus makoigi kono cost of transportation in rupees tani quintal number tab the 62.5 ni ahan bagi do go down a dagi DE after thaki bagi amuk sung makoigi respective quintal masinga purinera sum up tawrani. Asumna go down be dagi DE F option the tabagi transportation for to quintal amanda 4 to 3 ni hariba number singa siga makoigi respective quintal masinga purineraga phangani masina si simplify tawtosi actual simplify tawrabadi we get this. Thus, the LP with the linear programming problem is to maximize Z sigi value asi to minimize Z masigi value asigi minima asino objective function or any subject to the constraints x plus y should be less than or equal to 100 or any x plus y should be greater than equal to 60 or any x should be less than equal to 60 y should be less than equal to 50 x should be greater than or equal to 0 y should be greater than or equal to 0 haribasina mahaki formulation to kawe. The feasible reason is the shaded region A P Q R with vertices hariba inequality singa sige corresponding equation singa dugi graph yepada aikoina masi phangle aduga feasible reason adudi A P Q R hariba region asina orani with vertices singa dudi A gidudi line anisi solve toraga phange 60 0 ni P gisu line anisi represent toriba equation ani to solve toraga phange 60 40 Q gisu line anisi represent toriba equation ani to solve toraga 50 50 phange R gisu line anisi represent toriba equation ani to solve toraga 10 50 phange hariba point singa sida hariba at A da Z ki value to put on objective function da sinjalani x amas y gi point asida leba coordination sinjalaga phange. Similarly at P da Z ki value su put on at Q the Z ki value put on at R the Z ki value put on value mari phange 1 2 3 4 mayam sigi manung dagi minimum value di 5 10 sina ore. Thus minimum Z is 5 1 10 when x is 10 and y is 50. Hence the minimum transportation cost is rupees 5 10 when when 10 50 40 are transported from A and 50 00 are transported from B to shops D E F respectively. Hariba value singa si matak to pi horiba value singa asida sinjalaga phangbani. Question number 7. An oil company has two depots A and B with capacities of 7,000 L and 4,000 L respectively. The company is to supply oil to three petrol pumps D, E and F whose requirements are 45,000 L and 3,000 L and 3,500 L respectively. The distance in kilometer between the depots and the petrol pumps is given in the following table. depot sing asiga oil petrol pump sing asiga gi arapa sing adu makhada piri. Assuming that the transportation cost of 10 liters of oil is rupees 1 per kilometer, 10 liters ki thau ama kilometer ama transport to lupa ama lowi. How should the delivery be scheduled in order that the transportation cost is minimum? Karamna thado lagari thau depotagi pump or petrol pumps in the thau tharagadi paisa yamdana changadage. What is the minimum cost? Kwaidigi yamdaba paisa du suputu. This is also similar to above question number 6. For question number I, a fruit grower can use two types of fertilizers in his garden, brand P and brand Q. Uhai thaba amakhakna mahaki garden da fertilizer makalani P amasung Q koba ani seasonai. The amounts in kg of nitrogen, phosphoric acid, potash and chlorine in a bag of each brand are given in the table. Makaki table sida pire. Adugumba kg amada brand kudingmaki bag amada yaugadaba nitrogen, phosphoric acid, potash, chlorine haibasing ado kg da makaki table sida pire. Tests indicate that the garden needs at least 240 kg of phosphoric acid, at least 270 kg of potash, and at most 310 kg of chlorine. Adugumba test torubadagi phangapasinguri yamdrabada phosphoric acid se yamdrabada 240 kg season now, aruga potash na 270 kg season now, aruga chlorine na 310 kg dagi hena season na yaroi. If the grower wants to minimize the amount of nitrogen added to the garden, haibadi uhi thariba mi aduna mahaki garden da nitrogen se yamdaba sang the season na pami. How many bags of each brand should be used? Brand makal animaki bag kaya kaya laigadagi. What is the minimum amount of nitrogen added in the garden? Garden adu added to godaba yamdrabada nitrogen kaya no. Question number 8. Let X and Y be the number of bags of brand P and Q to be used to minimize the amount of nitrogen. Amount of nitrogen minimized yamdana season anabagi damak brand P amasung Q laigadaba number of bags to X amasung Y mathang sina lorasi. Let Z be the amount of nitrogen. Amount of nitrogen to Z na khangnadasi. Then the LPP is to minimize Z equal to thrice X plus 3.5 Y. Subject to the constraints, X plus twice Y should be greater than equal to 240. Haribasi 240 yamdrabada 240 season now haibani. Assume that 3X plus 1.5 Y should be greater than equal to 270 mark isu. Matangidi at most 3110 is yamabada season now arisi. And SY should be greater than equal to 0. Masi pawbana koina formulation kawi. That is the graphs of the equations corresponding inequalities sing asigi corresponding equations sing adugi graph sing putoksi equations sing asigi graph sing do zikot putok an the intercept from the tame ani subagi the x equal to 0 and y equal to 0 are the lines a b c d e f y axis x axis respectively tole is in this picture. The feasible region is the shaded region PQR. PQR have a shaded region as in a feasible region oigani with vertices PG adudi line and its represent or equation and its solved toroga fangi 140 15 Q are a point as isu line and its represent or equation and its solved toroga fangi 40 or 100 ni and R mahakisu line and its represent or equation anido solved toroga fangi 2114. At P, the value of Z is Sipange. At Q, the value of Z is this. At R, the value of Z is 550. Objective, thus minimum of Z is over Z ki quite people value is 470 when X is 40 and the Y is 100. What problem or vanina? What na kumsi? Therefore, minimum amount of nitrogen is 470 kg. 470 kg minimum amount of nitrogen is darkar oil. When 40 bags of brand P and 100 bags of brand Q, high river brand sing a sigi 40 100 bags sing a season of matam the masigi minimum amount of nitrogen is 470 kg fungan. Question number 9. Refer to question number 8. If the grower wants to maximize the amount of nitrogen added to the garden, how many bags of each brand should be added? What is the maximum amount of nitrogen added? From question number 8, we see that Z is maximum at 140, 50 and the maximum value of Z is 595. Therefore, maximum amount of nitrogen is 595 bags when 140 bags of brand P and 50 bags of brand Q are used. Maximum amount of nitrogen is 595. Question number 10. A toy company manufactures two types of dolls A and B. Market research and available resources have indicated that the combined production level should not exceed 1,200 dolls per week, and the demand for dolls of type B is at most half of that for dolls of type A. Further, the production level of dolls of type A can exceed 3 times the production of dolls of other type by at most 600 units. If the company makes profit of rupees 12 and rupees 16 per doll respectively all dolls A and B, how many of each should be produced weekly in order to maximize the profit? Let X and Y be the number of dolls of type A and B. Then the problem is to maximize Z equal to 12X plus 6Y. Profit to profit the respective number the profit phangani. Subject to the constraints X plus Y should be less than equal to 1,200 and X minus twice Y should be greater than equal to 0. X minus twice Y should be less than or equal to 600. XY should be greater than or equal to 0. The graphs of the equations ahanbagi equation the intercept from the thame ani subagin X equal to twice Y ni ahum subagi su intercept from the thame X equal to 0 Y equal to 0 are the lines A B C D E F Y axis and X axis respectively. The graph sing adugi comparison C or O F P C. Continue of question number 10. The feasible region is the shaded region of APC with vertices OGD 0 0 A which is solved to 600 0 P is solved to 1050 150 C is 800 400 At O the value of Z is 0. At F the value of Z is this. At B the value of Z is 15,000. At C the value of Z is 16,000. Thus, maximum Z is 16,000 when X is 800. X is 800 and Y is 400. Therefore, maximum profit is rupees 16,000 when 800 dolls of type A and 400 dolls of type B are produced in a week. Sayolamada hariba dol makal anisi putok lavadi me sayoldugi maximum profit sinising trato. Extra questions. Diet problem. Manufacturing problem. Transportation problem. Thank you for watching video.